Hel- Hello, grade 11s. Today we are going to be doing trigonometry together, and we are going to firstly address the rules of trigonometry. In trigonometry, we are sometimes given something like a cast diagram, and we are asked to solve a triangle, or we are just given cos 180 minus x, and we have to figure out which quadrant is that number belonging to, so that we can know whether cos, sine, or tan is positive in that quadrant. So that is what we will be doing today. And without wasting any more of your time, let's get into the video, guys. Now, in the first quadrant, where I have written Q1, all of this trigonometry, the sine, the cos, and the tan, that are all positive, right? So everything there, when you see 90, when you see sine 90 plus x, you know that in that quadrant sine is positive. When you see tan 90 plus x, then you know that in that quadrant tan is negative. When you see cos 90 plus x, you know that cos is negative. And when you see sine 90 minus x, you know sine is positive in that quadrant. When you see tan 90 minus x, you know that tan is positive in that quadrant, and cos, just like I have indicated. So let's say you want, this is from 0 here to 90, right? This is from 90 to 180. The numbers here will be from, the range here will be from 90 to 180. Then from 180 is 270. Then from 270 is 360. So where you have 180 plus x, 180 minus x, sorry, so that the numbers fall within the range of between 90 and 180. Here we are. Here is 180 plus x, 10 is negative. Here, 180 minus x, sine is the only one that is positive, just like I indicated with a plus sign. So in the second quadrant, sine is the only thing that is positive. Anything you see cos 180 minus x, cos is negative in that quadrant. So when you see 180 plus x, just know that tan is positive in that quadrant. When you see 360 minus x, just know that cos is the only positive in that quadrant. So let's say you are given something like sine 90 minus theta, right? This is what you are given, sine 90 minus theta. You must know that sine 90 minus theta is in the first quadrant, right? And sine is positive in that quadrant. But the rules of trigonometry says sine 90 minus theta changes to cos theta. This theta is still the same as this x, so you don't have to worry. They can sometimes give you this as an A, this is alpha, or B as a beta. So the signs of this can't change from different questions, and depending what the examiner would like to use. So when you see sine 90 minus theta, know that that's automatically cos theta. Even if it's sine 90 minus x, it will be cos x. If it's sine 90 minus beta, it will be cos beta. So that's what you have to keep in mind always, guys. And when you have cos 90, let's include the degree, minus theta, that is sine theta. And the reason why this cos and the sine are positive is because in that quadrant of 90 plus theta or 90 minus theta, cos, sine, and tan are all positive. So that is what you also have to know, right? Even when you are given sine 90 degrees plus theta, that is still going to be cos theta. are given cos 90 degrees plus theta. That will still be sine theta. So you see, whenever you see 90 and you see cos or sine, just know that they will change. Even if it's theta minus 90, it will still be cos theta. Or even if you have, even if here it was theta minus 90, this would still be cos theta. Or if you had, here is cos theta minus 90, this would still be this would still be sine theta. So that's what you have to know. That's one of the rules we have in trigonometry regarding that. And another thing that you can know is it's a very easy. You can write tan theta as sine theta over cos theta. There we have it. You can have tan theta. You can still write tan theta as sine theta over cos theta. But that one, we use it a lot where we do identities, or yes, when you are trying to reduce or all those stuff. You will see where we use it later in the video. So this is what you have to know, and then we can continue now to do some examples in order to increase our knowledge. So let's do one reduction example to enhance our knowledge, and say, let's say we have to express let's bring the boards so that we can tackle these questions. All right, here is the question. We are going to do reduction, right? So here in this question, we are asked to express sine 45, sine 126, and sine 45 as 36 degrees. So that is what we, as a ratio of 36 degrees. So we are going to use reduction, and that is where we are going to remember all that we did on the, all that we saw on our cast diagram that I had shown to you. So in this question, we have sine 45 degrees, and we have to express this as 36, as a ratio of 36 degrees, right? So how are we going to do that? We are going to say 90 minus 36. So not 36, sorry, 45. Or so that's how you will know that 90 minus 36 will give us 45, right? So we are reducing this in terms of 45. So that will be sine 90 minus 36 degrees. This is still the same as this. When you say 90 minus 36, it will still give you 45. Now we are supposed to express it as 36. So because sine is positive in this quadrant, we are going to have sine 36 degrees. We have expressed this sine 45 as a ratio of 36. So we used 90 minus, because when you say 90 minus the ratio that is required, we are still given the original sine number, which is 45. Now we'll move on to the next one. We have cos 126, and we have to write this as cos 36. So we have to check 90. Let's take 90 this time, because this is bigger, right, than 90. So we have to have 90 plus, not 90 minus, because this we have 90 minus. We use 90 minus because this angle is less than 90. So because this one is bigger than 90, we need to use the 90 plus rule. So let's say 90 plus 36. Well, that gives us 126, which means we can use it. So we're gonna say here, oh, remember, I hope you remembered, you corrected me on that rule that we have, that 90 minus and 90 plus, that changes to cos 36, right? So here as well, and here, let's write our cos as well. So I hope you understood what we are doing. This is the rules that I talked about, that cos sine 90 minus 36 changes to cos. Now we are here, cos 126, because you're going to use 90 plus, this cos needs to change to sine. That will be sine 90 plus 36 degrees, and that, because sine is positive in this quadrant, that will be sine 36 degrees. Look, we have done what we've been asked, and we have applied all the rules that we previously talked about. Now, the last one that you have is cos 45. You can pause the video and do this quickly before you come and check the answer. So here you have it. In fact, here we don't have to change it. You have to still leave it as cos, sorry, because that's how you're going to show that, oh, now we're writing something different. I got a bit excited. That's why I changed it early. So sorry about that, because when you have cos 90 minus, you know that this is what changes, not this. This is what qualifies to change as sine, not sine 45. So this is what qualifies to change, right? Okay, no, here I wrote it correctly, and then here I didn't write it correctly. So yes, we have sine here, and this sine qualifies as cos, not sine 45. Sine 45 is sine 45, but sine 90 minus 36 is the one that needs to be cos. And here, cos 126 cannot be sine, but cos 90 plus 36 needs to be sine. So here we have cos 45. You can do that quickly and then come back to check your answer. So now we have cos 45. We can say 90 minus 45 on your calculator, and that will give you, sorry, not 45 but 54. Yeah, I made a mistake here. It's 54, and here as well is 54. Yes, that's cos 54. So when we say 90 minus 54, you get 36. So that will be cos 90 minus 36 degrees. Right? What did we say this changes into? I hope you remembered that this becomes sine 36 degrees, and sine is positive in that quadrant. So here we have used the reflection and the rules that I have previously talked about in another video. Now what we are going to do is carry on with the video and do more of this question. We are going to be simplifying.